Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to be talking about heat energy transfer through the Earth and the interactions that the sun's energy has within the atmosphere. So let's start out with the three ways in which energies can be transferred within our planet, and that's going to include conduction, convection, and radiation. Well, conduction is going to be a good one because it's going to be heat transfer through a solid. Anytime a solid gets heated up, the molecules that make up that solid crash into each other, in which we call atomic collisions. Energy is then passed from one atom to the next. Eventually the entire solid heats up. A good example of this is a metal frying pan. Metal frying pans, not only are they good conductors of energy, they also heat up very quickly because they have a low specific heat. Notice that metal frying pans usually have a plastic handle, which is not a good conductor, so this way you can pick it up without burning your hand. The second form of transfer is what we call convection. Convection is going to be your heat transfer through a fluid. Now remember, anything that's a fluid is going to be anything that flows, like a gas or a liquid. Now this is a concept that's popped up a couple times. Plate tectonics, you get convection in the asthenosphere. You also get convection in your oceans that create ocean currents. You also get convection in the atmosphere that gives your wind currents. So you're dealing with density differences. Remember, low density rises and high density sinks. Think about how a lava lamp is going to work. The third form of energy transfer is what we call radiation. This can be heat transfer through space. It's basically the sun's energy that passes through space and reaches us. The radiation travels in the form of electromagnetic waves, whether it's short or long wavelength. We'll get into a little bit more detail about that in a second. Remember, you don't necessarily need a solid, liquid, or gas with radiation because space is a vacuum. Okay, so anytime you think about radiation, think about the sun's energy. Now, speaking of your electromagnetic spectrum, it's very important to know the difference between your different types of waves. Very simply because your entire spectrum is organized by wavelength, from gamma waves all the way up through radio waves. So you get your really, really long wavelength, and you compare that with your really short wavelength. So definitely know the differences between the two of them. With that being said, very important to know the differences. So with your long wavelength to begin with, these longer wavelengths are going to include microwaves, infrared, which is basically heat, and radio waves. These are a much, much lower frequency, much lower energy. There's not a lot of energy with these waves. And you compare that with your shorter wavelength, shorter wavelengths have a much higher energy. Those are going to include your gamma rays and X-rays, which are completely absorbed by the thermosphere. We know what ultraviolet waves can do, and visible light. Visible light is very intense because we can see it with our own eyes. You can see the color spectrum. Much higher frequency, much higher energy with these waves. So the energy from the sun, not all that energy is going to actually reach the surface. That would actually be a bad thing if that happened. Life would not be able to exist if 100% of energy came in and 100% of the energy left the surface of the Earth. Really only about 50% of the sun's energy actually makes the surface of the Earth and gets absorbed and gets used with different types of interactions. There are some things in the atmosphere that do get in the way, that do block a good portion of the sun's energy. So when you look at the energy balance here on the planet, you get a good majority of it coming in, good 50%, but one of the big blockades here are going to be clouds. Clouds are good absorbers, but they're also very good reflectors as well because they give off a lot of energy in the form of reflecting because of their white color. Very light colored material is going to be very, very good at reflecting. So a lot of that energy is going to get blockaded by our clouds. But there are some other ways in which the sun's energy never actually reaches the surface of the Earth. First off, we'll start with reflecting. This just means that energy can be redirected into another direction. Usually this is going to happen with really light, shiny, smooth surfaces, much like freshly fallen snow or perfectly smooth water. So what's going to happen here is energy comes in but gets reflected right back in the direction which it came from. Energy can be refracted, which means it can be bent. Okay, usually this is going to happen with differences in densities. And if you take a look, a good example of this is going to be when you put a straw into a glass of water. The glass, the water, and the air all have different densities. So the image of that straw is going to look broken up because the image of the straw has to travel through 3 different densities to get to your eye. It's going to look broken. That's what we call refraction. It's going to be bent. Scattering. just means that your energy is sent in many different directions. And good examples of this up in the atmosphere would be dust, water droplets, pollution, pollen, whatever it may be. Any kind of particulate matter in the atmosphere is going to cause for scattering, where insulation comes in and scatters in many directions. We can then have absorbing. We know that energy is going to be taken in by really dark, rough, dull surfaces. When you talk about dark surfaces, not only do dark surfaces are good absorbers, they're also good radiators of energy. They also give energy off as well. So continents, for instance, are a great example of good absorbers. They're going to take the energy in, but they're also going to give it off as well. And that's the last form of interaction, is going to be radiate, which just means that energy is going to be given off. Absorb means energy taken in. Radiate, energy is going to be given off. And again, it's going to be given off in the form of heat energy. Heat energy, another name for that is infrared, which is a long wavelength. And again, terrestrial radiation is going to be of a longer wavelength. Good absorbers are good radiators of energy. So hopefully you got down the 3 ways in which energy is transferred. Hopefully you got down the 5 ways that energy interacts with the atmosphere. And with that being said, we'll talk to you soon.